Now, another type of problem that you're going to have to be able to do is going to be doing something like identify something as a strong base or a strong acid. Let's look at 66 and feed those to me, and let's determine whether or not those are strong or weak. Okay? So what's A? Na. Na what?
OH.
I'm sorry?
OH.
NaOH. B.
NH3.
NH3. How about C?
H2SO4.
H2SO4. How about D?
HCl.
HCl. Okay, now, let me put a couple others down there. Let me put E. Let me put what's that? What's this? I had it on the board before.
Oh, it's ether.
Hmm?
Ether.
No. No, I put it on the board. That is what polyatomic ion. Acetic acid, that's right. And what chemical do you use in foods or on foods?
Vinegar.
Vinagre. Yeah, vinegar. It's the active ingredient in vinegar. Okay? All right. And what else? Let's see. What about, all right, let's keep it there. Let's see. Let's do another one. How about this one? Okay, now. Strong acid, strong base. NaOH. Anybody? And why? Kaylee, you got it? Okay. Anybody? Yes?
Strong.
Strong. And why would you say that?
Because sodium is a group 1 element.
Sodium is a group 1 element, and what is specific about group 1 elements when they're in a compound? Yes, Martha? They're very reactive, but they're very soluble. Yeah, they're very soluble. When you talk about a strong acid or a strong base, what are you really talking about? Okay, let's continue. So, sodium hydroxide is a strong acid or a strong base? And why? Strong base because sodium in compounds makes that compound very, very reactive, but very what? Very what? Sodium chloride, sodium bromide, sodium nitrate. Very what? Very what? Come on, guys. Very what? Soluble. But what more? I know you said that, I know. But it's not necessarily solubility that you're talking about. Sugar is soluble.
And then it dissociates.
It's dissociated. So it's a strong base, not because of its solubility so much as because of its dissociability. That's what I was looking for. You get it? It dissociates. It's soluble, yes, but sugar soluble. What it does is it dissociates into 2 ions completely. All of the sodium salts, including sodium hydroxide. So when you're talking about an acid or a base, that's what we were just talking about. What makes it a strong acid or a strong base? Its ability to do what? Dissociate. Understood? Its ability to dissociate. If I said, do you want to test what makes an acid a strong acid? And you said its solubility. I would say that would be incorrect. A weak acid is soluble. Weak acid is soluble. But the fact that it completely dissociates. So what's another way to tell if something's a strong acid or a strong base?
Where they are, like, group 1 elements or, like, I'm trying to explain. Like, if...
All right, let's, you know what? We're right here, so let's erase some of this, okay? And I'll show you, okay? All right, now. This is how and why something is a strong acid or a base. Okay, you ready? Okay, you ready? All right, because of this. You ready?
Running out of charge.
Okay, all right, thank you. Let me hook it up to a computer. Alrighty, now, I'm gonna have to do some serious editing on this one. But why not? What do? I'm just a teacher. Go here, try it. All right, now. Good, and that should be charging, hopefully. Okay, now. So let me show you why it's a strong acid or a strong base. Okay, you ready? Now, you know that an acid dissociation or a base dissociation works like this, okay? You have HA, correct? Now, HA goes to H plus A negative, correct? Even if it's a weak base, correct? And we said that this is 0.1, this is X, this is X. If I want to find the pH of a solution of an acid, right? Okay, now. And we said that the Ka expression equals what? What does the Ka expression equal?
Concentration of
It equals X squared over 0.1, where in reality it's going to be the product of the products over the reactant, right? Correct? Yes or no?
Yes.
Now, if I had 1 molar HA, and it was completely dissociable, it would be completely dissociable, what would the amount of H plus be?
0.1.
No, it'd be what? 1 molar, right? It would be 1 molar. If it's completely dissociable, it would have 1 molar H plus and 1 molar A minus. True or false?
True.
Yes or no?
True.
Okay, now, let's go this way. This was just, I did this to remind you of what? To remind you of that problem we did? Those problems, yes? So it would be this. You ready? It would be 1 molar over 1 molar. Right? What's 1 times 1? 1. What's 1 divided by 1? 1. 1 times 1, 1 divided by 1 is 1. So what would the Ka be? What would the Ka be for a strong acid? Equals 1 for a strong acid, right? Right? Correct, yes or no? Yes or no? Okay? It would be 1 for a strong acid. Yes? Or no? Okay, now. What would it be for a weak acid? Give me an example. In your book, you have Kas and Kbs in your book. They're called dissociation constants. You have a table of Kas and Kbs. Give me an example of a substance with a small Ka.
acetic acid.
Acetic acid. Good. Excellent. For acetic acid, and what's the Ka? for acetic acid? What's the Ka for acetic acid? What's the Ka for acetic acid? It's right in your books, guys. Come on. Ethanoic acid, acetic acid, what is it? If you memorize a Ka ever in your life, do it for acetic acid. What is it? Anybody?
1.8 times 10 to the negative 5.
Oh my god.
All right, so is that number less than 0?
Yeah.
Yes, it's less than 0? It's not less than 0, guys.
It's 0.0.
Is 0.1 less than 0?
Is that less than 0?
Oh no. Oh, less than 0.
That's what I said, less than 0. I said it several times.
Oh.
Okay? But is it approaching 0?
Yeah.
Okay, so this is the story. Are you ready? You ready? And then we're done. Okay? Can I erase this?
Yeah.
Okay, you get this so far? All right. Try to remember that this is a review. Yeah, okay, good. So, Ka approaches 1. Okay? Ka approaches 1. Strong acid or strong base? Strong. Ka or B? Strong acid, base. Ka approaches 0. Strong acid, strong base. Weak acid,
Yeah.
weak acid base. Weak acid base. You get that?
So it's approaching 0. It's weak acid.
Yeah, it's weak. And why is it weak? Why? Why? Because you have this. Watch. Ka equals this, right?
Yeah. 8 over 8 over 8.
If the acid, or this could be a Kb expression, same thing, Andrew, thank you, Kaylee, I appreciate that. If this number is small, if that's very small,
Yeah.
and that's large relative to that, is that number going to be large or small? Is the quotient going to be large or small? Small. This is the quotient. That's the quotient. What's that quotient represented by? What's that quotient represented by? The dissociation constant. That represents the quotient. Do you understand that?
Yes.
When that quotient is small, the constant is small. When it's small, it means it's weak. Large, or 1, it's big. Get it?
Yeah.
Michael.
Have a good one.